I'm Nithil. We are Group 4 and our final year project is titled Detecting and Resolving Online Ticket Fraud, Building a Robust Platform to Prevent Future Issues. In this project, we aim to develop an innovative solution to identify and address fraudulent activities in online ticketing systems, ensuring a secure and reliable platform for users. Today, we are presenting the conference paper titled Generating Synthetic Data for Credit Card Fraud Detection Using GANs, authored by Emilja Streltsenia and Simon Prockenwit from the Department of Creative Technology, Bournemouth University, United Kingdom. This paper was presented at the 2022 International Conference on Computers and Artificial Intelligence Technologies, and it has been cited 4 times, reflecting its growing relevance and the importance in the research community. To set the stage, let's briefly discuss why this paper is significant. Fraud detection in the credit card domain is a critical and challenging task due to the nature of the data. Fraudulent transactions constitute only a small fraction of the overall transactions, leading to highly imbalanced datasets. Such as imbalances pose a significant challenge to machine learning models as they tend to favor the majority class, thereby reducing the accuracy of fraud detection. The authors of this paper tackle this issue by utilizing generative adversarial networks, commonly known as GANs, to generate synthetic data. Specifically, they introduce a novel GAN architecture called KC-GAN designed to create high-quality synthetic data that balances the dataset. This approach not only addresses the class imbalance problem but also enhances the performance of fraud detection systems by providing better training data. The primary objectives of the paper are twofold. First one is to develop a GAN-based framework capable of generating synthetic data that effectively addresses class imbalances to improve the performance of fraud detection classifiers by training them on augmented datasets created using KC-GAN model. This research is highly relevant to our project as we face similar challenges. Obtaining real-world railway ticketing data is difficult due to privacy and security concerns, and the available data is often incomplete or imbalanced. By reviewing this paper, we aim to understand how synthetic data generation can be applied in our context to overcome these limitations. So, leveraging GANs to create balanced datasets will enable us to train more accurate and robust fraud detection models, bringing us closer to achieving the objectives of our project. In summary, this paper serves as a foundation for tackling data challenges in fraud detection and offers valuable insights into how advanced machine learning techniques can be employed to solve real-world problems.
Now I'll explain the methodology used in this research in detail. The authors introduce a novel deep learning framework called KC-GAN. This framework is designed to improve the quality of synthetic data generation, especially in scenarios where the dataset is highly imbalanced, such as credit card fraud detection. KC-GAN is built on the foundation of a generative adversarial network, or GAN for short. A standard GAN consists of two core components: the generator, which takes in random noise and attempts to produce data that closely mimics the real dataset. The discriminator, which tries to differentiate between real data samples and the synthetic ones created by the generator. These two networks are trained simultaneously in a sort of a game theoretic setting. The generator constantly tries to fool the discriminator, and the discriminator tries to catch the generator's fakes. Over time, the generator learns to produce increasingly realistic data. Now, what makes KCCAN different and innovative is the way it enhances the loss function used during training. Yeah, in traditional GANs, binary cross entropy loss is commonly used. BCE helps the generator produce samples that look real to the discriminator. However, looking realistic isn't enough when it comes to data like credit card fraud, where the distribution of data is crucial. So the authors introduced an additional term of to the loss function, the fullback Liber divergence of K.L. divergence. The statistical measure compares the probability distribution of the synthetic data to that of the real data. By minimizing the divergence, the model doesn't just generate realistic looking samples. It also ensures the distributional characteristics like the feature relationships and class patterns are similar to those in the original dataset. The dataset used in this research was publicly available credit card fraud detection dataset from Pegger. To address this, researchers pre-processed the dataset in two important ways. First, they applied principal component analysis to reduce the dimensionality of the dataset while preserving the most important features. This is not only help with computational efficiency, but also reduce noise and redundancy in the data. Then they used KCGAN to generate synthetic samples, particularly for the underrepresented fraudulent class, to create a more balanced dataset. This balancing is critical for improving the performance of downstream classification models. Finally, the authors carried out extensive hyperparameter tuning. Uh, they experimented with different learning rates, dropout rates, and optimizer functions to fine-tune the model's performance. These adjustments ensured that the training process was stable and that the synthetic data generated was both robust and realistic, not just visually or statistically, but in terms of actual predictive usefulness for fraud detection.
Yeah, moving on to the experiments and the research section of the research, to evaluate the effectiveness of the proposed KC-GAN framework, the authors conducted a series of experiments aimed at comparing its performance with both the original imbalanced dataset and other widely used oversampling techniques. They began by selecting five popular and diverse machine learning classifiers, named as random forest, logistic regression, multi-layer perception, XGBoost, K-nearest neighbor. These classifiers were trained separately on three types of data sets. So, the original is a highly imbalanced data set. Uh, then they oversample the dataset, created using conventional technique use such as which called synthetic minority oversampling technique, and AD adjacent, that means adaptive synthetic sampling. And finally, the synthetic data sets generated by the KCGAM framework. Also, uh, after that, by testing across multiple classifiers, the authors ensured that the performance gains were limited to just one algorithm, and they wanted to see generalizability across the different types of models. So, uh, therefore, by doing this, doing these kind of things, they have to their experiments. So, as the uh, results of these experiments, uh, the most noteworthy finding was the classifiers trained on the KCGAN augmented dataset consistently outperform those trained on both the original and other oversampled versions. Uh, and this uh, This held true across all five classifiers. Uh, the improvement was specifically evident when looking at the performance metrics tailored for imbalanced dataset, particularly the F1 score. Uh, Talking about the F1 score is the harmonic mean of the precision and the recall. In imbalanced classification problems, accuracy alone can be misleading. Therefore, since sometimes the model might just predict the majority class and still appear to perform well. But the F1 score reflects the model's ability to correctly identify the minority class. In this case, the fraudulent transaction, without being overwhelmed by false positive or negatives. With that in mind, one of the most impressive outcome was seen in random forest classifier, which achieved an F1 score of 0.9998 when training on the dataset enhanced by the K.S.E.K.N. This is remarkably close to a perfect score, indicating that the model was extremely effective in identifying both fraud and non-fraud cases. Uh, Also, the other classifiers such as XGBoost and NMLP also showed notably gain when trained on the KCGN data compared to the SMOT and adenosine. Uh, while the SMOT and adenosine do a decent job of oversampling, they often generated synthetic samples based on interpolation and can sometimes introduce noise or overlap between classes.
Okay. Uh, to conclude the presentation, the paper introduced KC-GAN, a novel GAN-based framework for generating high-quality synthetic data to tackle class imbalance. By improving the F1 scores across multiple classifiers, KC-GAN proved to be a superior approach for credit card fraud detection compared to existing oversampling methods. The authors also emphasize that their method could be extended to other anomaly detection tasks such as time series and network traffic data. Future work will involve refining the GAN architecture to improve accuracy and applying it to broader data sets. So this research is particularly relevant to our project detecting and resolving online ticket fraud. We face the challenge of obtaining real-world railway data, and this paper highlights how synthetic data generated using GANs can effectively address data scarcity. By adopting a similar approach, we can build balanced data sets to train our models, ensuring better fraud detection accuracy while preventing overfitting. This integration of GANs into our project will make our platform more robust and scalable. So in summary, the KCGAN framework is a powerful solution to a fundamental issue in fraud detection. Its application goes beyond just credit card transactions and can be a valuable addition to projects like ours, where data scarcity and class imbalance are ongoing challenges. As we move forward, adopting such techniques can help us build more intelligent, efficient, and secure fraud detection systems. So, thank you.